beautiful people, and welcome. In this video, we are talking about geometric series. Now, this is a review video. We have done the entire lesson with examples in previous videos, so this is strictly review. I'm going to try to do as many examples as I possibly can without making this video too long. I'm going to try. Can't promise that, but I am going to try. All right, disclaimer time. I am human. If I make a mistake, that is okay. Let me know where the mistake occurs, so that way I may learn from it, you may learn from it, and you don't have to make the same mistake. All right, let's go ahead and get started. So we're focusing on geometric series. So here in front of me, I have the previous notes for my geometric series infinite formulas and my geometric series finite formulas. I don't expect you to know these formulas. I do recommend having one sheet of paper where all your formulas are listed out. Highly recommend. All right, let's go ahead and get started. Determine if each series converges or diverges. Okay, now if you notice on this one in the summative formation or summative notation, you have infinity. So this is strictly for infinite series. So they go off to infinity. There is no ending to them. So it matters to us if it converges or diverges, because if it converges, right, if we converge, that means the R is less than 1, and we get to find what the summation is. However, if it diverges, the common ratio, the absolute value of the common ratio is greater than 1, and the sum does not exist. Okay, so how do we do that? Well, if it's in the summation form, there's literally not much you have to do. Look at the term that is the base to the exponents. So in this case here, this is going to be your R, and again, we're following the explicit rule for the geometric sequence here, and this is where your n or position number starts at 1. So this is your R value. So we need to check if the absolute value of R is either greater than, less than, or equal to 1. And in this case, the absolute value of R, or in this case, -3, is 3. 3 is greater than 1. So based off of our cheat sheet, right, that we have on our formula sheet, the 3 is greater than 1. This means this converges. Excuse me, diverges. The sum does not exist. This means it diverges. Now on the number 2, this one does not give us our common ratio. That is something that we have to find. Make sure you're finding it the right way. For a geometric series or sequence, we have the common ratio by taking your right number, dividing by your left number, taking your right number, dividing by your left number. Now you can do this if you want using multiplication. 2 times what is 8/5? 8/5 times what is 32/25? So you can do that, or you can use a calculator, which I prefer. So I have 8/5. I'm going to divide that by 2. Now this gives me a decimal. I don't want a decimal. Remember, we're keeping the pattern. If you see a fraction, you have to do it in a fraction. So I'm going to go ahead and switch that over to a fraction, and that gives me 4/5. If this one is 4/5 as well, that means that is our common ratio. If it is not, then that means this does not have a common ratio, and the sequence is not geometric. So 32/25 and 8/5. Oops, forgot my... Always do parentheses. Always do parentheses. Don't learn that the hard way. And I see the same decimal, so that means we have 4/5. If you still want to convert that to double check, there it is. So that means my common ratio, my R value, is 4/5. That means that the absolute value of my R value is less than 1. So this means this sequence, if we were to do a series, so if you were to add all of this up with our pluses, this converges. All right, let's move on. Sticking with infinite series, here is our summative notation, and it's asking us to find the sum. So the first thing you need to do is double check if your sequence converges or diverges. Again, if it diverges, the sum does not exist. If it converges, the sum does exist. We're going to start with our R value. The absolute value of R is, in this case, less than 1. Since it is less than 1, then it converges. So we're going to use our formula. And our formula, again, is S sub infinity, or you can just use S, is equal to A sub 1 divided by 1 minus R. Now, in this case, what is the first term? Well, we are starting with the lower limit of 1, so the term is in the first position. You can find this different ways. You can take this 1, plug it in here, and solve, or you can just use the formula. So the formula for the explicit rule, it means that the A sub 1 value is in front. In this case, it is 1. If nothing is there, that means it is 1. I'm going to do a quick thinking bubble here. Let's say you don't remember the formula. How do you find the first term? All you have to do is take the lower limit and plug it in. So if I have 1/4 to the I minus 1, and our lower limit is 1, so I would have 1/4 to the 1 minus 1 power. 1 minus 1 is 0, so that means I have 1/4 to the 0th power. Anything to the 0th power is 1. So again, if you're not sure how to use the formula to find the first term, just plug in the lower limit. All right, so let's go ahead and continue working on this. So our summation from 1 to infinity is 1 over 1 minus r, and 1 minus r is 1 minus 1/4. So here I have 1 minus, I'm going to just do this really quickly. This means I have 4/4 minus 1/4. So that means I have 1 over 3/4. And this just says 1 divided by 3/4, which is the same thing as saying 1 times 4/3. Again, take the reciprocal or just use a calculator. Keep in mind, this is a fraction, so do not give me a decimal answer. Only decimals with decimals, fractions with fractions. So that means we converge to 4/3, and that's going to be our answer. All right, let's go ahead and move on to example number 4. In example number 4, I'm looking for a cheat sheet here. I have no idea what happened to my cheat sheet, but that's okay. Let's go ahead and just move on. Find the common ratio. So find the common ratio. Common ratio is your R value of the infinite geometric series. So they have to tell you some information in order for us to know what to do. So we were trying to find the common ratio of the infinite geometric series. So that means it is a converging because a series does exist. So if it was diverging, the series wouldn't exist. So we start out with a formula. Again, you can put the infinity there just to let you know. Ooh, this should be A sub 1, 1 minus R. So S is your S of infinity, sub infinity if you want to call it that. So your S is 3/2. Your A sub 1, they tell you, is 1. And you're trying to solve for R. I'm going to go ahead and rewrite it here. There's a little bit more room. So 3/2 is equal to 1 over 1 minus R. Now this is where a lot of hiccups will happen. I can foreshadow a lot of hiccups happening. So I want to make sure I take this really slow. You have two options. This is the option I recommend. The other option is to go back to integrated math 1 and use that method. But this is the option I recommend. Always group your denominator together so you know this is one thing. You cannot separate the 1 and the minus R. Don't do it. The best way to do this, even if you don't have a fraction here, create a fraction here. You're going to flip it. So what you're going to have is you're going to have 2/3 is equal to 1 minus R over R. Excuse me, 1 minus R over 1. Okay, how did I do that? Because we have a proportion, right? It's fraction equals fraction. You can take both fractions and flip it over. So that's what I did. So now that gives me 2/3 is equal to 1 minus R. So I'm going to, you can add R to both sides and then subtract the 2/3, up to you. Or you can subtract 1. If I subtract 1 here, I get 2/3 minus 1 is equal to negative R. And again, you can use your fractions or you can use your calculator. So if I use a calculator, 2/3 minus 1, again, that gives me a really nasty decimal. We don't want decimals because we have a fraction. Fractions have to stay with fractions. So converting that to a fraction, that gives me a negative 1/3 is equal to a negative r. Therefore, my r is equal to 1/3. We're just solving for a variable. All right, let's move on to example number 5. Number 5 is asking us to evaluate from the lower limit to the upper limit. Now, this does mean that we have a finite series, okay? And the way we know the infinite versus the finite in summation notation is because we have a term on top. Previously, we had an infinity, that is infinite. If we have a term on top or the term number, the last number that we're going to add is in the 9th position. That means it's finite. So notice that we have a formula here. Look at your cheat sheet. This is the explicit rule for a geometric sequence starting at 1, which means in front of here I have a 1, which is my a sub 1 value. If the number doesn't exist in front of whatever your base is, that means it's a 1. Again, if you're not sure about that, just plug in your lower limit. All right, and we're trying to evaluate. So I'm bringing up my other formula, and my other formula says S sub n is equal to a sub 1 times 1 minus r to the n power divided by 1 minus r. Now keep in mind, this is your position number, your total position number of terms. Your a sub 1 is not actually the term in the first position, it's the term in the first position based off of your lower limit. For example, if the lower limit was 3, then you would use the term in the 3rd position, whatever number that is. R we know is a common ratio, n again must match, so it's the total number of terms. All right, let's go ahead and do that. Total number of terms is found here. You take your upper limit minus your lower, and you're going to add 1 to that, and that is equal to your total number of terms. In this case, we have your upper, which is 9, minus your lower, which is 1, plus 1. We still get 9. That doesn't always happen. If your lower limit is different, that doesn't always happen. Be careful. All right, so now let's go ahead and find our series, the sum. So we have S sub 9 is equal to S sub 1. In this case, we start at the first position. In the first position, we have 1. 1 minus r, again, r is always the base, which is negative 5. Be careful with the double negatives. Always put your r in a parenthesis so you can save yourself from a headache. Using calculator, always start with the exponents first. So I have negative 5 to the 9th power. That gives me a very large number. I'm going to do this right off to the side so you guys can see how I'm doing it. I'm doing negative 5 to the 9th power. That gives me a very large number. I'm going to then have 1 minus that number. So what I'm going to have is I'm going to have 1 minus, because I have a 1 minus here, and then I have negative 1953125. Now you don't really have to write this down. If you notice that you have 1 minus a negative, you're going to add 1. So you're going to do this. So technically, you don't even need a calculator for this. This 5 will become a 6 right here. Here I have 1 plus 5, or 6. So what I have is S sub 9 is equal to 1953126 divided by 6. That I will need to use my calculator for. 1953126 divided by 6. And that gives me 25,521. So when I add up from the first position to the 9th position, all of those numbers, I'm going to have 25,521. Again, there are no units on this. These are just integers. All right, let's move on to number 6. Again, we are evaluating this. Same formula. The formula doesn't change. Let me change my color. So number of terms. I'm not going to copy down the formula Actually, yeah, I will. It's going to make it easier. S sub n is equal to S sub 1 times 1 minus r to the n power divided by 1 minus r. So I have S sub n is equal to S sub 1. What is S sub 1? S sub 1 is the first term. Again, unless you have a lower limit that is something different than 1, your A sub 1 is just the first term. So 4 times 1 minus r, always put r in parentheses. N, they told you, is 6. So in this case, this number here, this n needs to be 6 as well. We're evaluating the first 6 terms. I don't know what r is yet, so I'm going to just leave that as a blank. 1 minus r, put r in parentheses. Okay, let's figure out what r is. That is our common ratio. So I'm doing 4 times what is 24? 24 times what is 144? And etc. So I'm going to just off to the side do division. I prefer to find my common ratio with division. So I have 24 divided by 4. I have 144 divided by 24. So 24 divided by 4, that is 6. 144 divided by 20